In this question, we have two blocks, M1 and M2, and it's a frictionless tabletop, meaning there's no friction, and connected to a string that passes over a pulley. So here it is the pulley, and this is one string that's passing through. They're giving us the masses. They are giving us the masses of the two blocks, and we need to find the acceleration of the masses and the tension in the string. Because there's one string, we only have one tension, and because these two blocks are connected by one string, we only have one acceleration or one magnitude of acceleration. So the first thing we are going to do is to look at what forces are in each of these blocks. So the first block, we can write a weight, so let's call it W1. And because this is on a table, we have a normal force, let's call it N1. And for M2, we have a weight, call it W2. There's no normal force because M2 is not on a surface. And then we have to consider tension. So when we are drawing the tension vectors, let's say for M1, we draw the arrow away from the object. So away from the object is tension T. So if you look at M2, we are looking at the string. Away from the object is tension T. Again, this is the same tension because it's the same system. So now let's go ahead and draw charts for each block. We have to draw a chart for each block. So if we look at M1, let's draw our force and X and Y components. So we have N1, we have W1, and we have tension. So for N1, we have a positive N1 and no X component. For W, there's no X component. And the Y component is negative W1, negative because it's directed at the negative Y axis. So if we take positive X here, positive Y. And then for tension, we have X as positive T, and then there's no Y component. And let's look at M2 now. So for M2, we have force and then X, and Y2, we have W2 and T. Let's write W2 and T. They both don't have an X component. Y component for W2 is negative, and then for tension it is positive. So what we can do here is look at each block and assign its own X and Y components, so X and Y direction. So M1 we drew it here, and for M2 we can draw positive X and positive Y. So let's look at first of all the acceleration. As you can see, this entire system is moving downward. So like M2 will be going down and M1 will be going to the right. So acceleration for M1 is going to be to the right, and for M2 it's going to be downwards. So let's look at the M1 chart here, and because M1 is traveling in the positive X direction, we are going to look at the F equals ma, our Newton's second law equation, in the X direction. So when you add the X components here, what we get is positive T, and then that is equal to m, which is m1 times acceleration. And as you can see, acceleration is positive because it's going on the positive X direction for m1. So let's just call it equation 1. For m2, because m2 is going in the y direction, is traveling the y direction, we will look at the y component of F equals ma. So this is what we are looking at here. So the summation of y components will be negative w2 plus t, and that is equal to m2 times a. Now we have to be careful. We see that a here is downwards, but we took y as our positive, y as upwards. So a is downwards, which means it is negative. So we have to be careful of the direction of the acceleration. And let's call this our equation 2. So from the first equation, we know that t is m1 times a. So what we can do is for t here, we can plug in m1 times a. So that gives us negative w2 plus m1a equals negative m2a. And we know w is m times g, and this is w2, so it is negative m2g plus m1a equals negative m2a. So let's isolate our a values. So we have m1 plus m2, because I'm taking the m2 to the left hand side, and then I'm taking the negative m2g to the right hand side, so that becomes m2g is positive. So dividing by m1 plus m2, we have m2g divided by m1 plus m2. Now if you plug in the values for m1 and m2, you should get 3.27 meters per second squared. So that is the acceleration. So that is part A. And then we have to find the tension in the string. So we can plug in this acceleration value to either equation 1 or 2. But let's just plug it in here because that's easier. So T equals m1, which is 1.5 kilograms, times A, which is 3.27 meters per second squared. And that gives us T equals 4.91 newtons.